Hello, AP Statistics students, and welcome to the College Board virtual instruction for AP Statistics. My name is Luke Wilcox. I am an AP Statistics teacher at East Kentwood High School in Kentwood, Michigan. Very happy to be here with you today. It is a very exciting day today because it is Friday, so happy Friday to you all. And what that means today is that we are going to be doing FRQ Friday, which means that I'm going to do my best to try and take you through 3 free response questions from released exams in the past and talk our way through the rubric so that you can see exactly how those are graded. So let's go ahead and jump right into things today. Quick check to make sure we are all in the right location here at AP Statistics. Hopefully you all know who I am at this point. A couple of quick announcements to start out here. If you are new to us for some reason today, you should know that we do this meeting every day, 2 o'clock, Monday through Friday, Eastern Standard Time. We are approaching the end of the AP exam review unit by unit through the College Board CED, right at the end of this week here, where we're finishing up units 4 and 5. So the FRQs that you see today will be coming from those 2 units that we talked about this week. Then looking forward to next week, Mr. Murphy and I have some excellent review activities planned for you for next week. And then this week of May 4th through the 8th is going to be AP Prep Week, where you are getting ready for all of your AP exams. And then the big day for AP Statistics is May 22nd for our AP Stats exam. Now, for all the lessons that you see here on YouTube, if you want to download the lesson in order to print that out, you can go to statsmedic.com/YouTube. Just find the date, today's date, and you will find the resources that you need in order to access for today's lesson. And a final announcement here, if you or a student that you know is in need of a device or internet access in order to be able to take that AP exam on May 22nd, make sure that you go to cb.org/tech. There's a form that you can fill out there to make sure that you have everything that you need in order to take that AP exam at home on May 22nd. Okay, so we're going to jump right back to the homework problem that I assigned you yesterday, where we talked about sampling distributions. We've got this multiple choice question to take a look at, so let's dig in. Here's what it says. A large school district held a district-wide track meet for all high school students. For the 2-mile run, the population of female students participating had a mean running time of 8.8 minutes with a standard deviation of 3.3 minutes. Okay, let me pause right there. They're giving us the mean of the distribution for the females, and they're giving us the standard deviation of the distribution for the females. And the population of male students participating had a mean of 7.3 with a standard deviation of 2.9. So this 7.3 is going to be the mean for the males, and this 2.9 is going to be the standard deviation for the males. Now it says, suppose 8 female students and 8 male students who participated in the 2-mile run are selected at random from each population. Let X bar sub F represent the sample mean running time for the female students, and X bar sub M represent the sample mean running time for the male students. So here's the question. What are the mean and the standard deviation of the sampling distribution of the difference in sample means? So we know right away that we are in the world of means instead of the world of proportions. And it is also very clear here that this is a 2-sample problem rather than a 1-sample problem. So there's a couple of formulas that we're going to need to remember here. The first of which is how to calculate the mean for the difference in sample means. So the mean of X bar sub F minus X bar sub N is really just equal to the mean for the females minus the mean for the males. And we actually know those 2 values. They're given to us in the problem. The mean time for the females was 8.8 minutes, minus the mean time for the males was 7.3 minutes, which is going to give us a value of 1.5. So as I look at my answer choices here, this one is incorrect, this one is incorrect, so A and B are no longer options for us here. Now it appears that we have to find the standard deviation in order to get the correct answer here. So in order to get the standard deviation of X bar sub F minus X bar sub M, remember, this is where we want to add the variances, okay? So if I take the variance for the females, that would be sigma squared F over NF. And then I'm going to add the variance for the males, which would be sigma squared M over NM. And that gives me the variance, but I want to turn that back into the standard deviation. So now I need to take the square root of that whole thing. Well, now I just have to plug in the values that were given to us in the problem. So it's going to be the square root of the standard deviation for the females is 3.3 squared over the sample size of 8. And the standard deviation for the males is 2.9 squared over the sample size of 8. And so when I look at those remaining three choices there, I see an issue right here in answer choice C. We would not subtract the variances. We know we need to add the variances. And the thing that I see missing here is I'm missing the squared in D. And it appears to me that answer choice E is going to be the correct answer. So hopefully you did okay on that homework problem. And we are ready to jump into FRQ Friday. So let me start with just a quick overview of what we are trying to accomplish here today. You know what to expect. You're going to be looking at some FRQs. What I'm going to do is I'm going to give you 2 of them from Unit 4, and then I'm going to give you 1 of them from Unit 5. And my general approach on these is to start by talking my way through the model solution. But then after that, equally important is talking through the rubric that was used in order to grade that particular question so that you know exactly what has to be included on the AP exam in order to get full credit. So let's jump right in. And we're going to start, like I said, in Unit 4. And this particular question is 2011, number 2. And the context of it is political party registration. So here's what it says. The table below shows the political party registration by gender of all 500 registered voters in Franklin Township. And so what I see here is a two-way table. And I notice that we've got male, female over here. And then if I look across the top, it looks like we've got the particular political parties. I guess there's 3 of them, party W, X, and Y. And then also just to make sure that we note that this two-way table has already calculated totals for us that we may need in order to solve some of these questions. So here's part A. Part A says, given that a randomly selected registered voter is a male, what's the probability that he is registered for party Y? Okay, this is a probability question, and it definitely sounds like a conditional probability because there is a given condition. And the given condition here is that the registered voter is a male. Now, what that means is that this is really the only row that we need to look at, the row for males. So given that we are in that row, we want to know what's the probability that he is registered for party Y. In probability notation, what we're looking for is the probability that the person selected is in party Y, given that they are a male. Well, since we are given that they're a male, we only look at that row, which means that the total here is out of 200. So that goes in the denominator. And then in the numerator, we want to know of those 200 males, how many are in party Y? Well, it looks to me like there are 48 that are in party Y. And if I plug that into my calculator, that's going to give me a value of 0.24. Okay, on to part B. Among the registered voters in Franklin Township, are the events is a male and is registered for party Y independent? Justify your answer based on the probabilities calculated from the table above. Okay, we want to know if these 2 events are independent. So you have to think about the meaning of independent. What that means is knowing whether or not the first event has occurred does not change the probability that the second event has occurred. Well, we've already done a little bit of work on this, right? We've already calculated the probability that the person is in party Y given that they are a male. We did that in part A, and we know that's 0.24. So the natural question is, what if they weren't a male? What if they were a female? Would that change the probability that they are in party Y? So what we need to find out then is the probability that they're in party Y given that they're a female. Well, we can calculate that. This is just another conditional probability, but this time the condition is that they are a female. And so now my total is going to be out of 300. And of those 300 females, I can see that 120 are in party Y. So that's 120 out of 300, which is going to give me 0.40. Now, very clearly, I can see here that if I know that the person is a female, the chance that they are in party Y is increased quite a bit. It goes from 24% all the way up to 40%. In other words, knowing whether or not a person is male changes the probability that they are registered for party Y. This means that those two events are not independent. So let's make sure we answer the question here. The answer to the question is no, and then we need a good justification here. So I'm going to say, because the probability of party Y, given that they're a male, does not equal the probability that they are in party Y, given that they're a female, these two events are not independent. Okay, so let's move on to part C here, and here's what it says. One way to display the data in the table is to use a segmented bar graph. The following segmented bar graph, constructed from the data in the party registration Franklin Township table, shows party registration distributions for males and females in Franklin Township. And so we see the distribution for females as well as the distribution for males. And I think I can see our calculations here. This party Y here is for the females, and that's the 40% that we calculated in part B. And then this is party Y for the males, and that's that probability that we calculated in part A. And because those two were not equal to each other, we said that those two events were not independent. Now, the next part of the question says, in Lawrence Township, the proportion of all registered voters for parties W, X, and Y are the same as for Franklin Township, and party registration is independent of gender. So this is a different township, but in this township, the two events are independent. Complete the graph below to show the distribution of party registration by gender in Lawrence Township. Well, in order for these two events to be independent, then we know that the probability that they are in one of the parties, given that they're male or female, has to be the same. And so what we need to do then is we need to calculate the overall probability of being in each one of these parties up here. So I'm going to show my work down here, and what I'd like to find is the overall probability of being in party W. Well, if I look at my table up here, party W has a total of 88 out of the 500. So if we turn that into a proportion, 88 out of 500 is telling me that 0.176 are in party W. And if those two events are independent, that should be true whether they're male or female. It should be the same proportion that are in party Y. So down here in my segmented bar graph, party W there. We want party W to be 0.176. Well, maybe that's right about here. And I need that to be the same proportion for the females as it is for the males. So this little block in the segmented bar graph represents party W. And we're setting this up so that those two events are independent. Now we need to do the same thing for the other two parties. So let's find the probability of party X. If I go back to my table, party X has a total of 244, and it's still out of this 500 here. So I'm going to do 244 out of 500, and that's giving me a probability of 0.488. Now, in order to draw that in the segmented bar graph, I actually need to know the total of these two. So the total of those two is 0.664, which would be, I don't know, about right here in the segmented bar graph. And so that means I can draw my next little breaker line there here, and then we can label this one as party X and this one as party X. And let's just go ahead and calculate that last probability, the probability of party Y. And if I look at my total up here, the party Y is 168 out of the 500. And if we turn that into a proportion, that's going to be 0.336, which we hope is what's being represented in this final little chunk here. Let's just go ahead and label that as party Y and party Y. And now, because these two conditional distributions look exactly the same, we can say that party registration is independent of gender. So that takes you through the model solution. What I'd like to do next is to talk through the rubric on how this would be graded. And just a quick review about how these rubrics work. The first thing that you need to know is what E, P, and I represent, because we're going to give each part an E, P, or an I based on the rubric. And what E represents is that you've done that problem essentially correct. P means that you've done that part of the problem partially correct. And then, of course, I means that it's incorrect. So we'll go through grading each section with an E, P, or an I. And then at the very end, we need to turn that into a score out of 4. All free response questions are worth 4 points. And so I will show you the way that you can convert that into a score out of 4 after we grade each part. Now, this one has 3 parts. So let's start by looking at the rubric for part A. What you needed in order to get E for essentially correct on this one is you had to have the correct answer. But not only the correct answer, you have to also have your work shown here. So the correct answer is 0.24. The work that I've shown is just this fraction here. That is sufficient for showing work on a probability question. The probability notation that I've included here is not necessary for full credit. What is necessary is the correct answer and then this fraction representing the work. Now you could earn a partial credit if you gave a correct answer of 0.24, but you didn't show any work. That would be worth a partial credit. And anything less than that would be an I for incorrect. Okay, let's move down to part B and talk about how this one was graded. So I'm going to write the rubric down here. This is the grading for part B. So here's the important thing to know for this rubric. There are 3 different probabilities that could have been used in order to answer this question. We looked at the probability of party Y given that they are a male, and we compared that to the probability that they are party Y given that they're a female. The other probability that could have been used to compare to either one of those is just the overall probability of Y, which we did calculate down here as 0.336. So here's what's needed in order to get full credit here. You have to have 3 components in order to get an E. So let me tell you what each one of those 3 components is. The first component is to have the correct computation of 2 of the values. And it doesn't matter which 2 probabilities you chose of those 3, as long as you've chosen 2 of them and you've done the correct computation for those 2. Then you get component 1. Component 2 is that you have to state the 2 probabilities are not equal. So somewhere in your solution, you have to state that those 2 probabilities are not equal. We did that right here. So we have our 2 probabilities calculated, and then we've stated that they are not equal. And then the final thing, component number 3, is the conclusion, where you're going to have to conclude that they are not independent. And we did that sort of a couple different ways. We said no first, but then we made it very clear that those 2 events are not independent. So you have to have all 3 of those components in order to get an essentially correct. For a partially correct here, you got to have 2 of the 3 components. Anything less than 2 components, and you're going to be stuck with an I for incorrect. Okay, and let's move down to the last part here. This is part C. And let's talk about the grading for part C. In order to get an E on part C, you have to show that the 2 distributions are the same. So it has to be the same distribution for males and females. And there are 2 components, right? So component number 1 is you have to have the correct proportions. And you can see those proportions here where we've calculated them, but you can also see them in the segmented bar graph, which matches the values that we calculated by hand. So we do have the correct proportions there. And then the second thing that you have to have is the correct labels on the segmented bar graph. So party W, X, and Y must be labeled in the segmented bar graph there. Now, a partially correct would be if you showed that they are the same distribution for males and females, and then you just had one of the two components. So maybe you forgot the labels, and that would drop you down to a partially correct on that one. So you have three different parts that you graded, each one with an E, P, or an I. And here is the rubric for turning that into a score out of 4. Pretty standard rubric here. You can see if you got all three parts essentially correct, that's what you need in order to earn a 4. A 3 would be 2 parts essentially correct and 1 part partially correct. And then there are several different ways of getting a 2 and a couple of different ways of getting a 1 there. Now, it is also possible to get a 0 if you don't meet any of this criteria. Okay, onward. Let's move on to free response number 2 for today, also from Unit 4. One of my favorite questions here, one that I often give my students on a chapter test. Says here, a local arcade is hosting a tournament in which contestants play an arcade game with possible scores ranging from 0 to 20. The arcade has set up multiple game tables so that all contestants can play the game at the same time. Thus, contestant scores are independent. I'm guessing that that's probably going to become important later. Each contestant's score will be recorded as he or she finishes, and the contestant with the highest score is the winner. After practicing the game many times, Josephine, one of the contestants, has established the probability distribution shown in the table. Crystal, another contestant, has also practiced many times. The probability distribution for her scores are shown in the table below. Part A, calculate the expected score for each player. Okay, well, I'm going to start by calculating the expected score for Josephine. What we have here, we have Josephine's distribution. We could think of this as being a random variable x, and then this as being the probability of each one of those values. And we know that we can calculate the mean, and I'm going to call it mean sub j, by just taking the sum of all of the x values and multiplying them by their respective probabilities. So in this case, we take each x value, like 16, and we multiply it by its probability, plus the second x value, 17, multiplied by its probability, and the third, and the fourth, and you type that into your calculator, and you're going to get an average value or an expected score of 17.7 for Josephine. Now let's do the same thing for Crystal. So for Crystal, it's going to be the mean of, I'm going to use a subscript of C here for Crystal. And we're just going to take each value and multiply it by its respective probability and then add those up. We've only got 3 values to work with here. And sure enough, you plug this into your calculator and you are going to get exactly the same expected value for Crystal. So to start out, it appears that these two players are equally good at this particular arcade game, right? They have the same expected value or expected score. All right, let's move on to part B. Part B says, suppose that Josephine scores 16 and Crystal scores 17. The difference, Josephine minus Crystal, of their scores is -1. List all combinations of possible scores for Josephine and Crystal that will produce a difference of -1 and calculate the probability for each combination. Okay, they've already given us one here in the problem. They said if Josephine scores a 16 and Crystal scores a 17, then we would get a difference of -1. Well, we need to calculate the probability of that. So what I'm looking for here is the probability that J is 16 and C is equal to 17. So this is an AND problem where we would think about multiplying probabilities. And they actually told us in the problem that their scores are independent of each other. So we just need to simply multiply these probabilities. So the probability that Josephine gets a 16 is 0.10. And the probability that Crystal gets a 17 is 0.45. So this is just going to be 0.10 multiplied by 0.45, which is going to give me 0.045. Now, that is not the only way of getting a difference of -1. One of the other ways we could get a difference of -1 is if Josephine has a 17 and Crystal has an 18. 17 minus 18 would give me a difference of -1. So we need to calculate the probability that Josephine gets a 17 and that Crystal gets an 18 by just stealing those numbers from the probability distribution. So that's going to be 0.30 multiplied by 0.40, which is going to give me 0.12. And there is one more possibility. That would be if Josephine scored an 18 and Crystal scored a 19. So the probability that Josephine gets 18 and Crystal gets a 19 equals, let's see, 0.40 multiplied by 0.15, and that's going to give me 0.06. And I think those are the only ways that we could end up with a difference of -1. All right, so let's move on to the next part, part C. Find the probability that the difference, Josephine minus Crystal, of their scores is -1. Well, we just did a whole bunch of work on that. They want us to find the overall probability that Josephine minus Crystal is going to equal -1. Well, we know there's 3 different ways that this could happen. It could be this, or this, or this. Because I'm using or here, that means I need to add the probabilities, also noting that they are mutually exclusive. So we're just simply going to take those 3 values that we calculated in the previous question, and we're going to add those 3 together. And that's going to give me a value of 0.225. Okay, on to part D. The table below lists all the possible differences in the scores between Josephine and Crystal and some of their associated probabilities. Complete the table and calculate the probability that Crystal's score will be higher than Josephine's score. Okay, they've provided most of the values for us here, but there's 2 that we need to calculate, and that's the probability that Josephine, so we're trying to do Josephine minus Crystal, -2 and -1. Well, hold up here. We just finished calculating the probability that the difference is -1. All I need to do now is to copy that value down, right? So here's a little AP exam tip. If for some reason you were really stuck on part C and you had no clue, you could just make up a value that's reasonable and carry that value down into the next part and still get credit for part D. But I think we have the right answer here at 0.225. Now, to get that remaining value in the table there, we have to note that adding all of those probabilities, we should get a value of 1. And so if I add up all those probabilities and I subtract them from 1, I'm going to get a value of 0.085. And now all of those probabilities will in fact add up to 1. And now to answer the final question, complete the table and calculate the probability that Crystal's score will be higher than Josephine's score. Okay, we want Crystal's score to be higher. Well, if that second number is higher, when I subtract J minus C, I'm going to get a negative value. So what I'm really looking for here is the probability that J minus C is negative or less than 0. Well, looking at my possibilities here, negative values, I could get a difference of -3 or -2 or -1. Those are the 3 possibilities. They are all mutually exclusive, so we simply need to add those 3 probabilities together. 0.015 plus 0.085 plus 0.225 gives me a final answer of 0.325. So remember, at the beginning of the problem, we thought that these players might be equally likely to win this game because they had the same expected value, but it turns out that the probability that Crystal's score will be higher, that Crystal will win, is 0.325. Okay, now let's talk about how this one's going to be graded. And this one works just a little bit different than the previous problem that we talked about in the way that it breaks down. For the grading, we're going to call these sections. Section 1 is part A. Section 2 includes part B and part C. This is section 2. And then the third section includes all of the parts of part D there. This is section 3. For each one of the 3 sections, we are going to give it a grade of E, P, or I. So let's talk about what's needed in order to get an E, P, or an I on each one of these. So let's start with how we grade section 1, which is part A. In order to get section 1 correct here, in order to get an essentially correct, you have to have the correct mean for both and work shown for at least 1. So you don't have to have shown for both of them. You only have to have work shown for at least 1. And when I say work shown, it could be the actual calculation with the numbers, which is like what we showed here, or you could show a formula that counts as your work shown. Now, partially correct would be if you made like a little bit of a mistake. One of the mistakes that students often make is that they round expected values. You do not want to round expected values or a mean. You can leave that as a decimal. It should stay as 17.7, not 18. And then one of the other errors that students sometimes would make on this problem is if they only calculated one of the expected values. So those are a couple of different ways that you could end up with a partially correct. Anything else would be an I for incorrect. Now let's move down to section 2 and talk about what's needed for full credit in section 2. So here's what you need in order to get an essentially correct. And this is a pretty long list here. There are 5 components that are needed for full credit here. So let's talk about these 5 components. Component number 1 is that you have to have listed all combos to get a difference of -1. Well, that's what we did here. There were 3 different combinations that would give you a difference of -1. Component 2 is that you have to have the correct answers for part B. And there were 3 answers for part B, this one, and this one. So that's component 2. Component 3 is that you have to show your work for part B. Well, showing the work is showing this multiplication that's happening here and here and here. So we do get credit for component 3. Component 4 is to have the correct answer for part C. Well, the correct answer for part C was this right here, 0.225. And you can probably guess what's coming next. For number 5, you have to show your work for part C. Well, showing the work in part C is showing that you are adding those 3 probabilities. So hopefully you're getting the message here that showing your work on your probability questions is very important. So you got to have all 5 of those components in order to get an essentially correct. Partially correct if you have 4 of the 5 components. Anything less than 4 components, and you are stuck with an I on this one. And let's get to section 3, the very last part here. Talk about how we would grade section 3. So in order to get an essentially correct, there are 2 components that are needed. First of all, you have to have the correct values in the table. And there were 2 of them, right? This value and this value have to be correct for component 1. And then number 2 is to have the correct final answer and shows work. So the correct final answer is here, showing the work is here. You have to have both of those in order to get component 2. And if you have both components, that gives you an E essentially correct. Partially correct would be if you had one of the 2 components. So we have graded this in 3 sections, each one giving an E, P, or an I. And then you would take that now and let's look at the rubric, which is going to look very similar to the one that we looked at before. In order to get a 4 here, of course, you got to have all 3 parts essentially correct. 2 parts essentially correct and 1 partial would give you a 3. Several different ways to get a 2, and then a couple of different ways to get a 1. Also remembering that you can, in fact, earn a 0 if you have less than what is established here. Okay, we have one final remaining FRQ for today, and it is from Unit 5 on sampling distributions. This is question 2014, number 3, the context of which is sick days. So here we go. It says schools in a certain state receive funding based on the number of students who attend the school. To determine the number of students who attend a school, one school day is selected at random. One school day is selected at random. And the number of students in attendance that day is counted and used for funding purposes. The daily number of absences at high school A in the state is approximately normally distributed with a mean of 120 and a standard deviation of 10.5 students. Part A, if more than 140 students are absent on the day the attendance count is taken for funding purposes, the school will lose some of its state funding in the subsequent year. Approximately what is the probability that high school A will lose some state funding? Okay, this is a very classic normal distribution calculation problem that hopefully you are comfortable with. I would always suggest that you start with a picture, and here's the picture of my normal distribution. And I always label it as capital N for normal, and then identify the mean and the standard deviation, which we know is 120 and 10.5. And I want to make special note here that this particular distribution is the population distribution. All of the possible days, and we are going to choose one of those possible days out of the population distribution. So the thing that we're trying to find here is we are trying to find the probability of 140 or greater. Well, let's make note that the center of this value is 120, that's the mean. And what we are looking for is 140 or greater. So I'm going to shade that in red. We are looking for that probability. Well, hopefully you feel pretty comfortable with area under a normal distribution. I'm going to use a z-score here. And in order to turn that 140 into a z-score, I need to subtract the mean and divide by the standard deviation, which is going to give me a z-score of 1.90, meaning that that 140 is 1.90 standard deviations above the mean. And we should be able to now turn that into an area. Now, we need a table A for that, which of course will be given to you in your formula sheet in tables. Here's my table A. The z-score was 1.90, 1.90 gives me this value for an area, 0.9713. So let me go back, 0.9713. But remember, table A tells you the area to the left. We are looking for the area to the right. So I need to do 1 minus that value. And that's going to give me a final answer of 0.0287. Now, some of you may have been trained or are familiar with calculator function, which will do this same thing for you. So let me make note of that. The calculator function is normal CDF. If you are using this as work shown, you need to make sure that you clearly identify your inputs. So 140 up to some very, very large value with a mean of 120 and a standard deviation of 10.5. I'm going to label each one of those: lower bound, upper bound, mean, standard deviation. And the calculator is going to give you almost exactly the same answer here. 0.0284 would be the calculator answer. All right, let's move on to part B. The Principals Association in the state suggests that instead of choosing 1 day at random, the state should choose 3 days at random. With the suggested plan, high school A would lose some of its state funding in the subsequent year if the mean number of students for the 3 days is greater than 140. Would high school A be more likely, less likely, or equally likely to lose funding using the suggested plan compared to the plan in part A? So now instead of picking 1 day out of all the days, we're going to pick 3 of the days at random and find the average of those 3. So listen, this is a different distribution than the one that we drew above. This is now a sampling distribution of the sample mean. And we know that the sampling distribution should be less variable than the population distribution. So I'm going to draw it a little bit skinnier there, clearly identify it as normal, and it will have the same mean as the population distribution, but the standard deviation is no longer 10.5. It is going to be 10.5 over the square root of n, which in this case is 3. So just in case you wanted to know, that gives us a standard deviation of about 6.06. So the difference between this distribution and the one above it is that now we are looking at the sampling distribution of the sample mean x bar. Now, we still want to know the probability of getting that 140 or greater. So we are looking for that area as our probability. I'm going to go through the same steps as I did just above. We're going to calculate a z-score. But of course, the z-score is going to be different now because my standard deviation is now 10.5 over the square root of 3. I'm going to get a z-score of 3.30, which means now we are 3.30 standard deviations above the mean, much farther above the mean, which I think means we're going to get an area that is much smaller. So let's go ahead and turn this into an area. Well, we're going to have to go back to our table here. and we need 3.30 this time. So let's see, 3.30 is 0.9995. Once again, we subtract that from 1. And that is going to give me a very small area here of 0.005 as a final answer. Now, very important here, we need to make sure that we answer the question being asked, which is we want to know if it's more likely, less likely, or equally likely to lose the funding. Well, this probability we got here is much, much smaller. So we want to make it very clear here that the answer is less likely. And let's make sure we give a good justification here. Because the probability that we just calculated, 0.005, is much less than the probability we calculated in part A, 0.0287. All right, and let's move into part C, which says a typical school week consists of the days Monday, Tuesday, Wednesday, Thursday, and Friday. The principal at high school A believes that the number of absences tends to be greater on Mondays and Fridays, and there is a concern that the school will lose state funding if the attendance count occurs on a Monday or Friday. If one school day is chosen at random from each of the 3 typical school weeks, what's the probability that none of the 3 days is Tuesday, Wednesday, or Thursday? So we want to know the probability that none of the 3 days chosen are Tuesday, Wednesday, or Thursday. Well, what that really means is that the first day that is selected is not Tuesday, Wednesday, or Thursday, and the second one selected is not, and the third one selected is not. Well, this is an and problem, and we can say that each of these days is independent, so we need to just multiply probabilities. So the probability that the first day is not Tuesday, Wednesday, or Thursday, well, that leaves me with only 2 days out of 5, right? Monday and Friday. And then that second being not Tuesday, Wednesday, or Thursday, of course, is going to be the same. And the third is the same. And because they are independent, we can multiply those 3 probabilities. And that's going to give me an answer of 0.064. So that takes care of our model solution. Let's now move to the rubric that's used to grade it. Pretty straightforward here, 3 parts, part A, B, and C. Each one has its own rubric for giving an E, P, or an I. So let's start with part A. In order to get a full credit E in part A, there are 3 components. Component number 1 is that the student has to clearly identify that they're using a normal distribution, and then also identify the parameters, which would be the mean and the standard deviation. Now, we've done that in a couple of different ways. Right here, we actually took care of everything. We've got the normal distribution, and then we have our 2 parameters. The other way that students can get credit, if they are calculating a z-score and they have clearly shown where they put in the mean and the standard deviation, that would also give them credit for component 1. And even if they use the calculator function, here's your normal, here's your 2 parameters, so they still get credit for component 1. Component 2 is to clearly establish what they call the boundary value. Well, the boundary value is this value right here, 140, which you see here and here, also shown in the calculator function there. And then, of course, the third is you got to have a correct answer on this one. And either the answer from table A or the answer from the calculator would be acceptable as a correct answer. All 3 components get you an E for this one. For a partial, you got 2 of the 3 components. Okay, let's move to part B. In order to get an essentially correct in part B, well, first of all, you have to clearly say or answer the question, right? The answer to the question is to say less likely, and you have to have the following 2 components. Component number 1 is you have to have calculated the correct probability. And the correct probability here is the 0.005. And then number 2, you have to compare this probability to the probability in part A. Well, that's what we've done right here by making the comparative statement that that value is less than the value calculated in part A. Now, partial credit on this one is if you missed component 2. Now, there was another way described in the rubric in order to get full credit here on part B that had 3 components. Number 1, somewhere you had to clearly identify that this is the sampling distribution for sample means, as opposed to the population distribution. 2, you had to say that the mean is the same as the mean of the population at 120. And 3, you had to state that the standard deviation of the sampling distribution is less. That was the other way that you could get full credit. Without actually doing the whole calculation, you could have just explained in words what's going on in this picture. And then the third part, part C here, in order to get an essentially correct, pretty straightforward here. You got to have the correct answer. And guess what? Shows work. We're definitely seeing this trend amongst the probability questions. So this, of course, would count as showing our work, and this would be our correct answer. Partially correct is if you have the correct answer and no work. There is one other way you could get a partial credit. If you use the multiplication rule like we did here, but maybe you had the wrong probability there, at least you understood that you were supposed to use the multiplication rule here, and you could still earn a partial credit on that one. So we've got our 3 components there, or our 3 parts that we've graded E, P, or I. We need to now convert that into a score out of 4. And I think that this rubric is going to look very similar to the first 2. All 3 parts essentially correct for a 4, 2 parts essentially correct, and 1 part partial for a 3, and then several different ways of getting a 2, a couple of different ways of getting a 1, and even a possibility of getting 0. So that was pretty quick. We hustled through 3 FRQs along with the rubrics for those 3 FRQs. Listen, I hope that that was beneficial for you to see how those are going to be graded by the graders. If this was beneficial to you, please give me a thumbs up there in YouTube. It is Friday, so I wish you all a happy weekend. We will be back again on Monday, and I look forward to seeing you all next week.